Good afternoon and welcome back to the workbench. So this is another video in the printed circuit board manufacture at home series, which will go into the details of the UV photoresist method instead of the toner transfer method. Now, because I've already done several videos on homemade PCBs, I'm not going to go into the steps like etching and stuff, which I've already done in previous videos. This video will only be about the steps unique to the photoresist method. So yeah, if you need to know the other parts, etching, etc., drilling, that kind of thing, cutting the board, you'll have to look at those other videos which are in this same playlist. And you can search on my channel for PCBs. It should come up with all those videos there. But anyway, so there's a couple of designs I've been working on which I want to make. There's one here. I've already done these boards. I've already applied the etch-resist to these ones, like for example this one here. You can see this purple etch-resist there, not toner, it's different. So I haven't actually etched these yet. I'm just waiting till I get this fourth one done, which I'm going to make this video about, and then I'm going to etch all these four boards at once. Now these three here are for a different design, so anyway, those are all already set up, so I'm going to do that later. But I've got another one that I want to make. So first of all, I'm just going to go over the things you need. You do need different equipment, obviously, and different materials, although some things can be used from the toner transfer method. So if you've already been making boards with that method, you probably have already half the required stuff that you need to make stuff with the photoresist method. So you will need a laser printer. Well, I would recommend a laser printer or photocopier. You can get transparencies that you can print on for inkjets, which you can use to expose your artwork. However, I haven't had any success with those myself. I have read on the internet people saying that it worked well for them and that's what they use, but my attempt at using that just came out with a terrible transfer. Too many holes in it. The ink was very thin and just not very good. So I don't know. I can't say I don't recommend them, but I can't say that I recommend them either. Something that, you know, if you've got access to, if you've got a good inkjet printer, I think you may have to use genuine ink. The cheap refills may not work. That may have been my problem. I was using cheap ink. Works fine for just standard paper, but you know, for something where you actually want to block light, it may not be thick enough. Anyway, so like I said, you need a printer, laser printer or photocopy is probably the best. That's what I use. You need something to print the artwork on. Now I use these here, OHP films, or OHTs these are called. These are designed for use with laser printers and photocopiers. You do want to make sure you get the correct ones. Obviously, if you run an inkjet one through a photocopier, it will just melt. So you do actually have to make sure they are these kind of things and designed specifically for photocopiers and laser printers. It should say that on them. These aren't plastic. These are some sort of acetate or something, I think. So these don't actually melt and destroy your printer. These I bought from company Office Max. It's $20 for a pack of 100, so pretty good. 20 cents a sheet. Pretty good value. Yeah, so you need those. I've also got a box of photoresist film, bought from eBay a few years ago, and some blank circuit board copper clad to put it on. Now you can buy pre-sensitized boards, which is basically a piece of board like this that's already got a film or some sort of paint or something applied to it. I've never used those. They do work well from what I've seen. The reason I wouldn't buy them myself, and why I probably don't recommend them if you're doing a lot of DIY stuff, is because if you make a mistake and you mess up with your mask, doesn't work, or you overexpose it or underexpose it or something, well then you've kind of ruined the board and you have to buy a new one or whatever. With this film here, this stuff's pretty cheap, so you know, if I mess up I can just take the film off, reapply a new film and then re-expose. So it's much easier, and you just can use the same piece of board over and over if you have to keep trying again. Generally though, it should work most of the time, first time, so up to you what you use. Secondly, if you are using some sort of film, you can also get paints, I think, as well, which do the same thing. I've never used those, and they do suggest you have these on some sort of centrifugal sort of device where you pour the paint on, and then this thing spins around and it all spreads out evenly. Seems a bit complicated. Might work well in factories or something, but yeah, for home stuff it's probably too much trouble, so I wouldn't bother doing that. But to apply this film, you need some sort of heating device, such as this laminator. So I've already got this, which I use for toner transfer, so I can use it for both. You can also use a clothes iron or hot plate or some sort of thing, but yeah, this needs to be sort of heated so it'll adhere to the board correctly. There are some other things you also need. You may or may not need. You need some kind of, well, I personally have a sort of little very budget light table sort of setup that I can use to align the masks that I print out. I print out 2 layers and align them on top of each other just to get a nice thick coating of toner. I do find the pinholes in the printer again cause problem if I just use 1 layer, so I have to use 2 layers. But it is actually easier than trying to copy it to this with the toner transfer method, and then trying to add the TRF foil with the laminator. It doesn't seem to always work. So just doubling up on a mask that's printed out seems to be a lot easier, as I've found. And I also find this method much more useful for doing designs that have very fine pitch components, surface mount things like QFPs or other such ICs, things like that, which is what one of these designs, and these ones here have a couple of surface mount parts on them. For example, this board here is not too bad. This one, I could have done this with a toner transfer method, but I figured I was going to get everything set up to do this one, which I'm doing soon, with this UV method, so I might as well do the whole lot at once with the same thing. You obviously need also some UV light to expose the film with. Now to that end, I've got another quite budget thing. I've got a bunch of UV LEDs stuck on a piece of proto board. And this works pretty well for small boards like this. These LEDs are probably spaced a little bit too far apart, but I'm going to build a proper exposure box someday for doing larger boards and just making things a bit less dangerous. Obviously this is quite high intensity UV light. You don't want to look at this directly when it's powered up, so yeah. Anyway, it's got a bit of a box, but for just cheapness' sake and for the fact that I don't use it much, I just have this at the moment. I do not recommend this at all. But yeah, it works. So, what else do you need? Yes, the final part, which is the confusing bit. You also need a developer for the UV film. After you've exposed it to light, you need to develop or wash away the parts between the traces that you obviously don't want, that you actually want to have etched away. Now there's a certain chemical you can buy for that. I forget the name of it. I'll put it in the description probably or something. And you can buy that on eBay, for example, from China in little bags, fairly expensively, and you can buy it from electronic hobbyists and supply stores for probably even more money. I found the cheapest solution is to buy some of these washing soda crystals. These contain either the same chemical or one that's very, very similar, and this works perfectly fine. I've been using this sort of thing for quite a while. You do have to take into account that the concentration in this is lower than it would be if you bought the pure stuff from a supply store or eBay or whatever. So you do need to use a little bit more of this than you would with the other stuff, but this is a whole 1 kg tub and it cost me like $3-4 or something. It's way cheaper and way easier to get, and I think it's just the best option. I don't know if this particular chemical will work with all photoresists. Some of them, like for example the negative versus positive acting resists, probably I think maybe use a different chemical, so you have to look at that depending on what you've got. But the basic cheap film you get off eBay seems to work perfectly with this, so that's what I use. Yeah, so, and then of course aside from that you need a drill to drill your board if you're going to have holes. You need, etchant and etc. Like I said, that's in the that's in other videos. I'm going to do that here. That's stuff you need for any circuit board manufacturer, obviously. But yeah, aside from that and the UV photoresist method, obviously that's all you basically need. You need the film, you need a board to put it on, you need something to put it on with, and you need something to expose the board with afterwards. You need your printout, and you need something to develop it with afterwards. Also, this can be used to strip the all the resist off finally after you've etched the board. You could use sandpaper or something as well, but this works much faster. In fact, it's actually easier to take off than the toner, so that's kind of a nice bonus. But of course, in comparison, you do need extra equipment, you do need more stuff. It's a little bit more expensive overall than the toner transfer method, but that's the way it is. Now obviously you do have to have an actual board design to make, and there are some steps you have to go through to make sure that's all correct and everything's set up for this process. So I'm just going to go on the computer now and I'll show you in detail how that's done. Okay, so here's the design of the board I'm going to make today. It's not the best layout, I guess, because I've sort of crammed it onto the smallest piece of scrap board that I had lying around. So don't take this as a lesson in decent board design. Like I said, we've got these sort of wire links for some of the power rails and ground and stuff. It's not like the best thing, but it should work. I've done worse layouts than this a long time ago that still worked fine. So to be honest, in terms of quality, I don't think it's going to be an issue, but certainly I don't think it's best practices for a lot of what I've done here. So yeah, don't read too much into this. Anyway, it's all just about demonstrating the photoresist method of etching boards, so it's kind of irrelevant what the design is anyway. I'm just using this because the parts I'm using, I've got these very fine tracks, and I've got this QFP version of the AVR microcontroller that I'm using, and I've got this surface mount USB thing. The pads on this are like 0.3mm wide and about like 0.6mm pins pitch spacing between the pins, so very sort of small things, and doing that with toner transfer method is not always the best. But anyway, I've got my finished design, so what I want to do is print it out. Now, because I'm using negative photoresist, I need to print it out inverted than you would if you were doing the toner transfer method. Of course, if you're using positive photoresist, you would want to have it printed out the same way as you would normally, but for what I'm using, negative resist, and most resists are negative as it happens, so in most cases you'll need to invert the image. Now, for example, I don't know about all EDA programs, but KiCad specifically doesn't print out inverted if you do the normal print function, which is not really useful anyway for doing actual transfers. This is more useful for just sort of like documentation sort of printouts. You can use this, but I don't like using it myself. It will do mirrored versions, so if you are doing a toner transfer thing, you can mirror it and all that if you need to, but in terms of printing, I don't use the print function in this really at all. What's more useful is going to plot, and you choose, in this case, choose SVG, that's what I choose, and then you choose your options for what you want, depending on what you're doing. So in this case I want to choose this one, negative plot here, because I want it inverted, and everything else I choose drill marks to be small. Usually it seems to be the best way of doing it. You can choose actual size, but I've found that using small just puts like a little dot and it sort of gives you a pilot hole in the copper, but doesn't sort of cause any issues. If you have a really big pad, you want to drill like maybe these mounting holes here, it's more useful to have the actual size, but for most holes I've found that using the small drill marks option is the best. Anyway, so I'm going to just plot just the back copper layer. That's the green one. I'm not going to do the front layer, obviously. We've got the wire links here, but I'm not using that as a layer. These vias aren't actually going to be vias. These are just going to be links of wire, basically, where these red lines are. This one's obviously going to be insulated because it's right next to these pads, these leads here. So we got 4 wire links. That's it. Everything else is just on the other side. So all we want to do is just plot this back copper. Now, if you were doing a double-sided board, obviously you need to plot both and make sure that you do get the layer around the right way. So you may want to mirror one layer and not mirror the other. Depends how you're setting everything up and how you're printing it. What is worth noting though is when you print out to the transparency, you do want the toner side that's actually printed on to be against your board when you expose it with the UV light, to make sure that light can't seep in through the edges, otherwise you end up with like a sort of feathered edge and it doesn't etch out very well. But anyway, I'll get to that later. But yeah, so we just want the back copper and SVG. You can do other stuff, but SVG is probably the best option. For this case I'm excluding the edge layer because I don't want to have it on there, but usually I do keep it on there, but in this case I don't. Plot footprint values, this is irrelevant. That can be on or off, it doesn't matter, because on the copper there's no values anyway. So all I'm doing is, these are more useful if you're doing Gerbers to send away to a board house, but everything else is irrelevant. So we plot that. So it's part of this SVG file. Now I'm just going to open that with Inkscape and I'll show you what I do next. So here are the project files here, and here's the plotted SVG. If I just open that with Inkscape, we can see what it's done. Now I'll just zoom in here. So we got this thing here. I didn't actually bother plotting the mounting holes because it doesn't really matter. They don't have any high tolerance for where they are. But if we go back to the board, you can see that because of this USB and because of this dimension that I had to get everything lined up, it's gone and sort of plotted this background thing quite large out the side, which would be a waste of toner if I wanted to print this. So first of all, what I'm going to do is I'm going to select all the actual artwork here. I'm going to Control G to group that so I can move it around. Otherwise, if I had this ungrouped, you'd be able to move different traces separately and you'd mess up the whole layout. So now that I got this all together, I'm going to select this black background part. I'm going to choose dimensions in millimeter. I'm going to set this to the actual size of the board. So it's not on here, but the dimensions of this are actually 51 millimeters across by 34. So I'm going to set this to 51 by 34, and it's going to have to do it twice because sometimes it doesn't get the dimensions accurate straight away. And if I can Control A to select everything, I'm just going to go to Object, Align and Distribute, and we press this one here, center horizontally, center vertically, and now they're both lined up. Now I can select everything and group all that together. So now we've got our final sort of mask design. As you can see, it's backwards, it's inverted, which is exactly what I need. So again, depending on what process you're using, whether you're using positive or negative resist, and how your printer works, I mean in general, which that shouldn't really be an issue in terms of which way around you do it. I mean, you could flip it this way. Normally you wouldn't want to print it this way. Most of the time you'd want to be printing it mirrored, but inverted definitely for the case of this. I can, I think, invert this with Inkscape, but it's a bit annoying. yeah, it's better to print when you're plotting it in KiCad to choose negative or not when you plot it here. It'll make it easier than trying to invert the colors in a different program. So yeah, I'd just advise that. You can do it in here, but sometimes like the pad holes, the little dots for that, sometimes don't invert properly, and then you lose the drill marks, and I don't know, it depends what software you're using, depends on how it'll work, but yeah, I try not to do that, because it depends whether it's plotted those as separate dots or as part of the, yeah, sometimes it just goes a bit funny, so yeah, I wouldn't do that. Of course, if you're using a different program and you can't plot it inverted, or you can only plot it inverted, then I guess you have to do it in here. But yeah, you have to just watch out with that, because I have had problems before where different layers and stuff and getting the thing. Anyway, but now I've got this all set up, I can print that out, and definitely worth doing a test print. So when you go print here, I don't actually have a printer installed on this computer, I printed on the other one. But obviously, make sure your scaling is set to 100. Make sure, all your setups, or like that. You got, no borders or anything like that. And when you do print it, to check the dimensions of the page, check it out to make sure it is actually correct. Because sometimes printers will do some sort of weird scaling, or if you have a setup. It's in this, for example, if your page size is set incorrectly, or you've got some sort of funny thing going on, you've chosen the wrong DPI or something, then you can get it to be comes out slightly enlarged or reduced and incorrect. So you definitely want to actually measure the printout and make sure it is the same as what you actually designed in your CAD software. So anyway, so back to the workbench. I'll show you the actual printout I've made, and we'll continue on from there. Alright, so here's my printed out design, which I've just shown on the computer there. I've actually printed this out several times. Here's 4 here, 5, 6. This is the final one, which I'm happy with. I had to do a lot of mucking around with the USB port pins and that, because the pin pitch, like I explained, was quite small, and to get the thing for these ports, which I'm going to use, well, use one of these, I had to tweak the dimensions and pin spacing and that to get that correct. So that's the final one that I've got. Now, like I said, I have measured this, and it's exactly 51 by 34. As I mentioned in the previous segment. So you do want to do that to make sure that everything is the right dimension there. And I have verified that. You can just set your piece of board over top of it and see it all makes perfect sense. So yeah, obviously check all that. Check that your parts, like I said, if using these little USB ports here, check everything actually matches up. You can do that with the paper, just standard paper printout. Everything else is fine, and then of course you want to print this out on an actual transparency, but of course, so you don't waste your transparencies, yeah, do a test print on paper first. So while the obvious choice is OHTs, because they're completely clear, you can also, if you can't get these or if they're too expensive, I believe you can use thin paper like tracing paper, that kind of thing. Obviously, because it doesn't pass the light as easily as clear plastic or whatever these are, tracing paper will you'll have to do a longer exposure with that, or have a higher intensity light to get the same amount of time, but it doesn't really matter, it just means you have to wait longer or whatever. But these are, like I said, the obvious choice is what I use, and I can get them easily and cheaply, so I do. So yeah, so before I just print out my final design, what I'm going to do is transfer the film onto this piece of board. I will just close these so I don't get too much light sunlight on it. I don't want to prematurely expose it. And I'll grab my laminator back. Plug that in. So this film here, I bought this from eBay about, I don't know, several years ago. I can't remember actually, but they claim that this stuff only lasts for like 6 months or something, but like I said, I mean, I bought, I don't know, about 20 sheets of this, A5 size, had it for years, and it still works. So yeah, I don't know. Your mileage may vary, but for me that seemed to work fine. Now I also need some sellotape. I forgot to mention that, but yeah, there we go. So you grab some of this, scissors obviously as well. So you've got a couple of little scrap bits here. I don't think that'll, no, it's too small. Okay, so I'll take a piece of this. So I just want to cut this to the relatively correct size for this. Doesn't have to be exact, but you kind of want to have it close enough, especially if you feed it through a laminator. Otherwise it'll get the trailing edge, if it's too long, get wrapped around the rollers and stuff like that, so that's not particularly useful. So I'm just going to hold this on here. Now you can touch this fine because it's got plastic covering on it, and that's alright. So there we go, so there's a piece there. I'm just going to, I suppose I'll have to order some more of this actually. Okay, so now I've got my little piece of film cut out. I need to take the protective plastic, like I mentioned. I have to take that off one side so I can actually stick it to the board. I'm just going to turn the laminator on now to get it to heat up a little bit. So we take 2 little bits of tape. So the trick to this is you tape the tape on one side and then on the other side, and then you just pull apart like this, and it sometimes doesn't work the first time. There we go, now you can see the plastic is separating from one side of the film. So now I've got this here, so I'm going to start at one end and push this down and just go across really slowly, and just sort of push this down as I hold it up, and just make sure I don't get any air bubbles or wrinkles in it. So it's a little bit tricky. Apparently you can use water if you're doing a larger area, for example, but for these small little boards I've found you can just do it dry and just push it on by hand like this. So I've got that on there, and no wrinkles, no bubbles, that's all good, that's what we want. Now I'm just going to trim this just a little bit closer to the edge here. And now that I've got that there, I can just pass it through here. This is warm enough. It doesn't have to be at full temperature, just warm enough. This is will go up to like 250 to melt toner, so I don't really want it that hot anyway. So I'm just going to stick that through there. And that'll come out the other side just soon. So it does, I'll just grab it. There we go. So that's nicely adhered on there, just fine. So now I'm just going to hide this in this piece of cloth to let it cool down and make sure the light doesn't go on it. Put this aside here, and then I'll print out my final copy onto some of this film, and then I'll show you what we do next. Okay, so I've just gone and printed out the design on this piece of transparency, and I've printed it out twice because I want to double up the toner to get a nice dark image to block the light properly, because my printer isn't that great and it leaves holes and sort of thinner patches somewhere, and it's not very good. So with just one layer it wouldn't work properly. Now if your printer is good, or you're using some other sort of device, then potentially you only need one layer, which would be quite good, in which case you don't really need this light box thing, which I'm going to use to align the two layers when I cut them out. But of course in this case I have to do that, and also if I was doing a double-sided board, I would also need to use this as well to align the two sides of the board. Now you can, of course, even with toner transfer, you can do a double-sided board if you you can sort of pre-drill pilot holes in the blank copper and then line those up with, you know, registration marks on your two layers and that, and it is possible to do it, and I have done it before, but it is quite tricky and annoying, and it's certainly easier to do double-sided board with this kind of method here. So this light box is actually really cheap and really basic. I mean, it's a wooden box, wooden fruit box in fact, and we've got a little light in here. It's one of these incandescent Sylvania strip light things, 60 watt, and I've got the diffuser panel out of an old trashed LCD monitor. So if you get a monitor with a cracked panel or something, you can get some nice things out of it, like these diffuser sheets, whatever. You can also use perspex, of course, or even a piece of glass, but you know, it's a little bit more dangerous. It might have sharp edges or it could break, sort of thing. So this is pretty good. If you're really I was going to say really desperate, but if you're really cheap, you could even do this by holding it up to a window, and just sort of hold these on the window pane and use the sunlight. I did in fact try that the first time I did this, but it's very painful and tedious, and I really wouldn't recommend it whatsoever. So it's a good idea to get something like this, even if it's a really basic thing. Doesn't have to be fancy. I mean, this works fine. Just make sure that the light is actually diffused. I mean, this tube that I've got in here has got quite a good diffusive coating on the inside of the glass. If this was like a bare light bulb, it would just shine straight in your eyes and be pretty horrible. So you want to get a frosted bulb, or maybe some diffused LEDs, or if you do buy like a piece of perspex, to get one that's like a actual frosted sheet, not a pure clear one. This is not really frosted. It shines the light through quite well, but like I said, because the bulb has got the frosting on it, it doesn't matter. So it's not straight in my face and blinding me. So now I just need to cut these out. So like I said, I got the two copies here. I'm going to cut one with quite a wide area around the design. Now let's see, that'll be this one. And then I'm going to cut this one with a smaller sort of border. So I've actually got some space to overlay the tape and everything like that. So this one, just cut out here. Now, the other thing which is important to note, which I didn't really mention before actually, I don't think, but I'll mention it again anyway if I have already done that. So when you've got your design printed onto the paper, obviously it's going to be printed, well, not paper, it's plastic. When it's printed onto one side of the transparency, obviously the toner will be on one side, physically on one side, and not on the other. And you might think it doesn't really matter which way around it goes, but you definitely want to print it out in a way that means that the actual side that the toner is printed on, where the actual toner plastic is, will come in direct contact with the board when you're exposing it. If you have it around the other way, then even though the transparency is very thin, that distance will basically, the toner will be separated from the board by the thickness of your transparency, whatever that is, and that will allow for a little bit of a gap between the artwork and the board area, which would allow light to come in through the side around the edges of the design, and that will well, around the edges of everything basically, and that will cause like a feathering sort of effect on the on every edge. And if you have very fine traces, it may even eat away at them significantly to the point that they get overexposed and break, and it's not very good. So you do want to make sure that the actual printed side, where the toner is sitting right up against the board when you do that, so that there's no gap between the toner, which is blocking the light, and the actual surface of the board, the etch-resist that you want to expose. So yeah, so depending on which way you're doing that, just make sure you set up your printer and whether you're mirroring or not the image, so that when it's printed out, that the side that you want to have right against your board is always that way round, because otherwise you will get problems. And so I'm going to take my, like I said, cut this one larger, cut this one smaller. I'm going to take the larger one, put it on here, and then I'm going to tape it down to the surface of this box thing. It's running out of tape as well. So I'll tape that down here. And then I'm going to pull it tight and tape it down on another edge. And I should probably get myself an actual tape dispenser. But hey. Okay, so now I've got this little piece of glass which I'm going to use to just hold this down. It's just a little piece of glass out of a photo frame. But it provides a little bit of weight to hold this down, and also it's a nice small piece so that it doesn't overextend past the edges of this plastic that I've cut, and therefore I can actually still touch the plastic and move it around. So I can use the little mounting hole things in the corners. I actually did change the artwork to include those so it was easier, and I also changed one of the LEDs from a surface mount to a through hole one because it would be on the wrong side of the board. So then basically it's just a question of just staring directly down at the thing and maneuvering the design around until everything lines up. If you find that doesn't happen, if you find that you can never get it aligned properly, and when you've got one edge aligned the other edge is out, you may be facing a problem which I've noticed with a lot of printers is they're quite non-linear. And what I mean is that when you print something on a page, it is not dimensionally accurate across the entire page of printing. So what I would normally do, because I want 2 copies of this, is just to go into Inkscape and copy the graphics twice, side by side, and then print them out on the same sheet, right next to each other. But I have noticed recently that trying to do that can be a problem, especially with some board like this where you've got some very fine traces. So what I've done, because you see what happens is the printer prints out one image, and then as the paper goes through, the next copy of the image is actually printed slightly different size, maybe like 0.5 or less of a millimeter stretched or compressed or something on the side of the page, maybe due to differences in roller speed or something, you know, as the page goes through, whatever. What I found the best idea is to print one copy on the page, like maybe in a corner here like this, and then to flip the thing through and print it again on the other side, and that ensures that it's printing in the exact same place on the transparency. Well, not in the exact same place, but it thinks it's printing on the same place, and so you get the same dimensions. Obviously you want to flip the thing around so it's not actually printing over the top of the other design you've just printed. But yeah, if you see what I mean, so if you try and print two copies at once in the same document, they often don't actually line up when you do this. So it's much better to either print two completely separate copies on two separate transparencies, or to print like in one corner or on one end and then feed the transparency through again round the other way and print the other copy, but to the printer it thinks it's printing on the same location. So everything is geometrically and dimensionally the same, or at least a lot more similar than if you do two copies at once on the same page. But anyway, yeah, just an extra thing to note that I've found out over time. So anyway, back to this. So it's not a hugely tricky thing to do. Okay, so you just look in it, eyeball it a bit. Remember, of course, parallax error is possible, but because the layers are so close to each other, it doesn't really apply. But yeah, sometimes it takes a little while to sort of get things all lined up, and really, you want to make sure that you know, if you do have like a little bit of an issue, like with the images not lining up perfectly, it's better to get something like your main IC or something in the middle lined up more accurately than say the mounting holes in the corners, which aren't really that important to be lined up. Doesn't really matter. So anyway, so I'm just going to make sure that's good. And now I shall tape this smaller piece down to the larger piece. And once again I've lost the end of my tape. Okay, so I'm going to hold this down here, make sure everything is good, I don't want it to move, and then I just tape this down. This is nice and even. Now we can kind of take this off and not necessarily need to use it, but it's always a good idea to just do another check just to make sure everything makes sense. And if it doesn't make sense, just take the tape off and move it again. But in this case, everything seems pretty good. So here's just a little close-up of the artwork just to show you what I see here. And you can see the two layers are pretty much aligned. Just about as perfect as I can get. There's like some minor discrepancies, but you know, it's pretty good. So there we go. But yeah, it all looks pretty good, so I can just take this off and finish taping down the other sides. Probably not necessary to tape all the sides, but you know, just to make sure it doesn't move again. It's pretty annoying if you go to all this trouble to get things lined up and then they move around later on. It's obviously also worth noting that you want to make sure your transparency is actually clean. Whoops, doesn't have any dust on it or anything. If you get pieces of dust trapped between the sheets or between the mask and the board, you will obviously end up with little bits of holes or whatever in the design that shouldn't be there, or bridge tracks or whatever. So that's not a very good thing to do. But there we go. So that's all nicely done. So now I can just take these bits of tape off. And that's my finished mask there. Works quite well, and obviously if I was to do a double-sided board, I'd just make one of these, I'd make another one with the other layer side, and then I'd have to tape this down upside down and then do the other one on top and align that and then tape it. And then what I do is the taping these two double layers together is I would have tape around only 3 edges, and then I'd leave a gap in the middle, and that's where I'd slide my piece of board in between the 2 layers. But obviously I'm not doing that today, so I just need to make this one mask. So that's that part done. So now I can put all this away. Okay, so now I've got my little artwork here all printed out and aligned and everything, and it's all good. It's time to expose the board and use this to actually transfer the design. So to do that, I've got my little array of UV LEDs, as I mentioned before. And it's also, of course, worth noting this is not a safe way to do it. You really shouldn't do something like this and just have the light source bare. I know I'm doing it, but for demonstration purposes and for the fact that I'm not going to go and stare directly into the LEDs or anything like that, it's not a big deal. But yeah, if you're doing this seriously, you're doing a lot of boards, you definitely need to get a proper exposure box or make one. There's lots of designs on the internet how to do that and stuff like that. But yeah, don't look directly into it, don't hang around for too long. I'm not going to be in the room while this exposes because it takes about 15 minutes. The UV light coming out of these LEDs is obviously the same as UV light that comes from the sun, and it'll give you sunburn basically, and if you look into it, it'll burn your eyes and cause possible damage. I mean, it's not going to make you go instantly blind or something, but you really don't want to look at this strong UV light in general for any long amount of time. It's just not a good idea, so just bear that in mind if you are doing this, and make sure it's not, if you have kids or something, you don't want to have this sitting around and some little kid comes up and wonders what the pretty blue light is and sits there staring at it for like 20 minutes. That really wouldn't be good. So yeah, stuff like that, you want to make sure this really is in a box. But for this video, for the purposes of this, it doesn't really matter because I'm not going to be staring at it. But anyway, as I just said, 15 minutes is about the time it takes to expose this for my setup. That's going to depend on how many lights, what the brightness of your lights. It's going to depend on the material for your mask. It's going to depend on your etch-resist brand, whatever, composition sort of thing. So if you've never done this before, you kind of need to calibrate your setup and find out how long you actually need to expose the image for, because if you underexpose it, then when you go to develop it, your tracks and stuff will just come straight off and the board will be useless. You'll have to do it again. If you overexpose it, then it's possible the light will get through the mask a bit too much and you'll end up with holes around in places, or bits of resist on the board where you don't want them, depending on whether you're negative or positive. Stuff like that. So you got to get the optimal time. Now it's not like super critical. I mean, I can get a decent exposure with my setup anywhere between like 14 to 16 minutes, so you got a fairly good window there, for me anyway. Other stuff might not be as tolerant, but hey, there you go. So there are 2 ways to calibrate your setup. The first is to buy an official sort of exposure gauge thing. I think you can get them at photography supply places. I think they're designed for maybe use in dark rooms for doing film or something. But the cheaper way to do it is you don't have to bother with that. Do it sort of cheap and nasty. Cheap and nasty. Quick and dirty sort of way you can do that is to take your board. So I got this wrapped up here to prevent too much light going on it. But you take like a board, just get a blank piece. You've just got the film on there, or the paint, or whatever you're using. We don't want the artwork for that at that point, so what we'd do is take this board and you'd take you get 2 fully opaque objects so that the light won't be able to pass through them. It's good. Rule is pretty good because it has the steps on it, and then what you do is you'd cover like half your board with, say, this rule, and then the other half you'd cover with, say, this card, and then you've got like a little piece here, say 5mm on the end there. So you take your LEDs, whatever, you expose that for say a minute, and and then you take those off, move this piece here across like another 5mm, expose again, move this 5mm, expose again for a minute. So you keep moving, set increments of distance, and keep exposing for set increments of time. And what you'll end up with obviously is a gradient of steps going from one end of the board to the other, and then under this half you'll end up with a completely unexposed section. And then what you'll have, so like I said, you'll have like steps going along this edge. It'll be completely unexposed here, and you want to look at, for a start, which has a nice clean line between the exposed and unexposed. As this exposes, it gets more darker and goes purple. And then of course you want to develop this in the developer solution, and then you'd look at where the etch-resist actually stops washing away, where it's been exposed enough that it can it doesn't come off when you develop it, and you want to see where this so all the unexposed stuff would come off if you're using negative resist, and then you'd want to get a nice clean line between what that is, and then you'd count the amount of steps that was, and that's how many minutes you want to expose for. So yeah, it's a kind of rudimentary way of doing it. I'm just going to do this in here again so we don't get too much light. So yeah, that's a way of calibrating. Yeah, I don't know, I can't really give a ballpark figure. Like I said, mine is 15 minutes, but for anyone else it could be anywhere between 5 to like half an hour, depending on the strength of your light and whatever you're doing. I mean, you can even just set your board up in your artwork and leave it outside under the sun, for example. I don't know how long that takes, but some people do it that way. But yeah, so that's the way you have to do that. But now I'll actually get on to actually exposing this. So the first thing I'm going to do is I'm going to tape this down to the table so it can't move. So I've got a piece of tape that I've rolled over and made a double-sided, so I'm going to tape that down here so that can't go anywhere. Now I've got my artwork there, and I can align that. I've got another piece of tape here, so I'm just going to check that and make sure it all lines up with my piece of board. Make sure everything makes sense, and then I'm going to tape this down to the table as well. Actually, it's probably better if you take that on the long edge, not that way. This stops it from skewing around sideways. So now I'm going to take this bit of plastic and put that on top. So we got something that sort of heavy and holds the mask up against the board nice and tight. And then of course I can move this over the top here, and then that's going to just shine down through this plastic and expose the board. So I've got my power supply here. This is on 12 volts. These are set up with resistors for 12 volts. So what I'm going to do is get my sunglasses, get my phone. I'm going to set my phone to 15 minutes because that's about how long this will take. Where's the clock on this? Oops, 15. Okay, so what I'm going to do, I'm going to turn that on. Turn that on, turn this on, and then I'm going to run away. So I'll be back when that's finished. Alright, so there we go. That's the board should be all correctly exposed now. Yeah, so we can just move this out of the way and take this off. Just going to lift this up here, and yep, it looks really good. Here we go. Here's a close-up of the board, so you can see the difference between the exposed and the non-exposed areas. You can see the traces all come out pretty well. There's like a little blemish here, but where that text is, but that doesn't matter because that's not important to the circuit. And if I just zoom in a little bit here, you can see even these very fine traces have come out really well, and there's not a big deal there. Everything's pretty good. This wouldn't be as easy to get with the toner transfer method at all. So yeah, this kind of thing is pretty good. I mean, there's a little bit of issue in some areas, like this here, but that again doesn't matter. You can see the lighter areas where it hasn't been exposed. That's the part that the developer solution will wash off, and the darker areas should stay on since they've been exposed fully. So there we go. I'll just leave this in the dark there to cure a little bit, and then I'll get the developer solution mixed up, and I'll show you how that works and how to do that. So that'll be the next part of the process. But yes, the exposure seems to have gone well. There's very nicely defined edges, no big issues. Like I said, the only blemish in the film was where that text was, so that doesn't really matter. And that's all came out really well. So I can take this away anyway. And I can put that away. And if I ever want to make another one of these boards, all I have to do is just pull this mask out and do another one the same way. So it's quite good compared to the toner transfer method. If you want to make a lot of boards, or you may in the future want to make another of the same thing, you don't have to bother printing out the artwork again. You just take your mask out and just redo it. All you have to do is just get another piece of board, which you'd have to do anyway. So yeah, I'm just going to, like I said, just wait for that to sit around a bit, and then I'll come back in a second and we'll do the development. Okay, so now I've let the board sit around a bit, and I've gone and done some other things. I've come back and I've set up to do the developing. So, like I said, what you need is your washing soda. I've got 2 cups, one of hot water, one of cold water. I've got a toothbrush, an old toothbrush, plastic container, glove, and some tape. So now I'm going to grab my board here, which is still hiding in this cloth, and I'll show you what happens next. So at this point it's still sensitive to light, so I've still got the blinds closed. We don't want to leave this out too much. Now we take a piece of tape, once again, and we have to take the other piece of plastic off the etch-resist. So again, taking the tape on top of the plastic covering, and you should be able to just get that on there and pull it, and there we go. That has come right off. So if we left this on here, we wouldn't be able to do anything. It wouldn't develop, it wouldn't etch, nothing would happen. So we have to take that off. Now I've got some sort of overexposed bits around the edges where there was no mask. You can pull those off with your fingers like this. It's kind of good to get these off first, and it's also why you don't want to have too much resist over the edge of the board. But we can pull this off, and that will dissolve in this anyway, but well, may or may not, depending on how exposed it is. So it's a good idea to kind of pull it off if you can. Anyway, so that's nice and open there, so that's good. Now you've got to mix the developer solution. So to start with, I'm just going to take some of these crystals. Now, if you're using the official mixture for this, you'll be given instructions on exactly how much to mix with how much water and all that. With these, it's a bit sort of different because the ratio of this, these crystals are not pure; they're like 50% water anyway. So you know you're going to have a different ratio depending on what brand of these you get and that sort of thing. So I just found it was I take about like a teaspoon or so. So maybe a couple of, I don't know, let's see. If you can see that, that's more than a teaspoon, that's probably 2 teaspoons, but you know, there we go, that's about that much. You don't need a whole lot for developing, you don't want too much. just in case. But anyway, you put that in there. Now I put the hot water in. So the hot water will dissolve the crystals to some extent, and then the cold water will just bring the temperature down so that the developing process doesn't go too fast. It also provides more water, so the solution is more diluted. Now I can put the board in there and it'll start developing straight away. And now I'm going to put this glove on just to make sure I don't get this on my hands. It's not like toxic or something, it won't instantly give you burns or anything, but it is kind of mildly sort of well, it's not the best thing to get on your skin. It won't kill you, it won't make your skin all fall off or anything, but you know, you don't really want to touch it. So yeah, if I just grab this, we can take the toothbrush or any sort of brush that's similar and just start sort of scrubbing at the board. Now you might think this is a bit sort of violent. It's not really. If your etch-resist has been applied correctly and it's all been exposed to the right level, if everything makes sense, then you know you're not going to get any issue with this at all. It won't rub the exposed parts off. If it does, then you have problems that you'd require the the etch-resist would come off while etching anyway, or something, if it was that weak. So you shouldn't really have a problem. But you can see, if this thing will actually focus, you can see the copper is starting to show through very quickly. So it doesn't take very long to develop at all, to dissolve the unexposed areas of this negative resist. We just want to clean it off like this. I mean, once you see all the copper is cleaned, you don't want to leave this in there for too long, otherwise it will start attacking the etch-resist that is where you want it. Once everything looks good, and it pretty much does now, I think this is pretty much done. So hang on, I'll just get that in a shot. You can see the copper is nice and clean, everything looks good. So now it's time to rinse this off in some just plain water to make sure it doesn't keep exposing. And now at this point, it doesn't matter about leaving it out in the sun or anything like that, because all that will happen is the exposed parts will just get harder and harder, and they'll just stay on there, but they won't cause any problem after that. So there we go, that's the development of the board finished. So I've rinsed it off to make sure it doesn't keep having a reaction with the etch-resist there, otherwise you could get like pitting or undercutting or some sort of thing. You do need to rinse it off afterwards, but now it's basically ready for etching. So you can see the etch-resist there is really nice and clean, very well defined, which is exactly what you'd hope for and what you'd expect. Assuming your mask is good quality and the light you've got there is good, then you should get nice results like this. So here's a close-up of the developed etch-resist. You can see again these lines are very nice and fine, they're very well defined. These holes here on this pad, this part here is not that great because the masks weren't perfectly aligned in this corner, but like I said, it was more important to get bits like this QFP to be aligned than it would be to get these corner parts, and there's still enough spacing between this track and this land here. I can use a pin to sort of scrape those little sort of tags off in that area, and I probably will, because it could cause a solder bridge, but I mean, even as it is, it's not completely unusable. But yeah, yes, for the most part it's pretty good. You can see these pins for the USB ports are nice and neat there. No issues there. Yeah, I mean basically overall it's pretty good. I mean there are some areas that I might need to do a little bit of touch up, and we can see with this X, this text here, that was where there was kind of a thin patch in the etch film. So yeah, that's damage there, but that doesn't matter, that's just text. The rest of it, everything else is pretty much fine. So yeah, it's come out really well. So I just might scrape off those little bits there. They look a bit dodgy, just in case, and then after that I'll etch it, and then the final thing will be to come back after I've etched, and I'll show you how the etch-resist removal happens, and then that'll be it. That'll be the end of the video. Okay, so it's sometime later. I've etched all my boards there, and I had dinner and everything, which is why it's sometime later. So now it's time to remove the etch-resist here. The easiest way is with more of the washing soda in a higher concentration. Of course, you could just sand this off or whatever, but it's a lot easier to just do it this way. So basically the only difference with this is this time I'm going to use more of the crystals. Probably about, I don't know, 4 to 5 times as much. And I'm going to use less water, and it's going to be hot. And we want to keep it hot. So put that in here. Make this more concentrated this time, because we want to try and strip all this off. So previously this would resist the developer solution, but now we want to take the whole thing off. Obviously, well, maybe not obviously, but normally you'd use 2 different chemicals for this. I think the one that strips this off is actually more active than this, but you can get away with just making this more concentrated, and it works just as well. So here's the board, nicely etched. You can see now the yellow fiberglass of the substrate is showing through, so everything's etched nice and clean, all looks good. So I'm just going to put this in here. So you should see the etch-resist there starting to peel off. At least from some of the smaller traces anyway. I'm just going to try holding this down so I don't burn my finger. There we go. You can see like on just down here, these tracks are starting to come off. Well, the tracks aren't coming off, but the etch-resist for those tracks is starting to come off. It's kind of an awkward position to do this in. But yeah, you can see as I sort of scrub at those, the etch-resist is starting to come off there, starting to sort of dissolve around like these parts here. I might just stick these all in and leave them to soak for a while, and then I'll maybe resume filming once they've all actually had a time to do something. Well, as soon as I stop filming, stuff starts to happen. So let me just try to get a close-up view of these. You can see the etch-resist is all actually popping off by itself. So you can see how these are all just floating free now. So it's all come off very easily. Except for these little bits here where I touched up with the pen. There were bits where I thought there were little bits of wrinkle, and it might have made like a pitting thing or something. So, you know, this one here is starting to go. That's all just falling off quite easily. So yeah, that's the effect I was expecting to happen. That's how that all works. It just all comes off like that. So it's yeah, a lot less effort than trying to scrub at it with sandpaper or something. Yeah, I had to do this this board here to do a lot of touch-ups on this one. For some reason the etch-resist just didn't expose properly. I exposed it for the same 15 minutes as all the other boards, but it just didn't seem to work properly. I think it needed to go for longer or something, but I don't know why, because I cut it off the exact same piece of material that I cut the one that I just did this from, and this one worked perfectly. So yeah, that was kind of strange, unless there was some sort of contamination on it or something. But anyway, that was a bit odd. These bits of pen that I've done the touch-ups with, I will have to take that off with a Scotch pad or something. This one hasn't done anything yet. But yeah, maybe just have to wait a bit longer. But you know, there we go. That's one that we've been doing today. It's just about all done. So yeah, it's just these spots here where I've got that Dalo pen. I just need to go and take those off manually, I think, because all the photoresist is already dissolved away and come off. So anyway, so that's it for that one. You get to see the effect. It just flakes off, assuming that the solution is concentrated enough and it's hot enough. So there we go. So I'll just stop here, and I'll come back once I've sanded off the residue of the pen. Okay, so here's the finished board, all nicely cleaned and all the resist taken off. You can see the copper came out really nicely. Everything looks really nice. There are a couple of tiny little problems. Well, not really problems, but just little things that are worth pointing out. I'll just zoom in and I'll show you what I mean. For example, on the pins of the QFP here, there's these little sort of copper spikes there. This one here is almost bridging from the 5-volt rail to ground, so I will have to deal with those. There was maybe one over here as well, but that's a no connect, although there will be a pin there, and there was maybe a little dot between these. Those are easily fixed with a sharp knife blade, just to scrape them off. I don't know if I can show that here while holding the camera steady. It probably won't work, but yeah, it's a good idea to check for this kind of thing when you do make a DIY board, whether it's with the toner transfer or this method or something else. It is sometimes possible to get little shorts, well, almost shorts between pads and things. So yeah, to scrape those off with a sharp tip of a sharp knife blade, or some sort of other implement, is obviously necessary, or well, highly advised anyway, because something like this is possibly going to cause shorts later on. So yeah, you definitely want to inspect everything like that before you solder your board together and then wonder why it doesn't work. But apart from that, it's pretty much done. So all I have to do is just scrape those little points off and, well, tin it, drill it, and solder all the components on, and then it should be done. Okay, so that's my 4 boards all done, and that's how you make a circuit board using the photoresist method with UV sensitive photoresist. You just need to make a mask image like this, print that out, and you can transfer it to your board. And there we go, that's the board all finished. Well, again, like I said, need to drill it, tin it, and all the rest, but etching and all that is all done. Looks pretty good. And you can see the other ones also came out very nicely as well. So yeah, that's that. That's the process of doing that. It's a little bit more complicated, I guess, than doing toner transfer method, but definitely for very fine pitch components like that and things, it's definitely better, I find. Easier to get a more reliable and consistent result. I'm not saying you can't do it with the toner transfer method. If you have decent paper and a good quality printer, you definitely can, but this way I've found personally is easier for delicate stuff. There you go, you can get away with quite a lot of sort of cheap things. Like I say, you don't need to buy the specific developer and stuff. You can just use washing soda, you can get some cheap film from eBay, you can get some cheap LEDs on a piece of board. Like I say, don't recommend this for safety reasons, but it does work. So there we go, hopefully that video might be useful to someone, and hopefully you enjoyed it, and I'll see you next time.